So far, we've already discussed expressions and statements, as well as compound statements, a sequence of statements treated as a block of code that can appear anywhere a single statement can appear. But what if you could give one of these compound statements a name, and call it by name in various places, rather than having to repeat the code? That's what functions are, a named sequence of statements. Not only that, but a function can accept arguments and return a result, making it somewhat generic and reusable. Useful programs are often made up of hundreds and sometimes thousands of functions. Hiding statements inside functions has many benefits. It can help to make it clear what code is doing. It makes it easier to test your programs. You can test a single function in isolation and then rely on it in various other parts of your program without worrying that it might be wrong or different copies of some algorithm might accidentally introduce inconsistency. This function is called a function definition. It includes a return type, in this case int, a name, Celsius to Fahrenheit, and a list of parameters in parentheses. Finally, it includes a function body. Every time you call this function, it's as if you had inserted this function body as a compound statement. But the code only appears in one place, making it much easier to maintain and test, and making the rest of your program simpler because it doesn't have to be complicated by all of these details. This also reduces code size, as code isn't repeated in many places. Reducing code size tends to have a big impact on program performance. Conversely, small functions are often inlined by the compiler, meaning that the compiler will actually duplicate the code if it thinks that there is a good performance benefit of doing so. As with global variables, all a particular source file needs in order to use a function is a function declaration, and these are typically provided in header files. This function declaration is exactly the same as the function definition, except that the function body is replaced by a semicolon, in effect hiding the implementation. The implementation, or function definition, can then be included in a separate source file and compiled separately. Indeed, this is often the case. In this example, and indeed in all cases, C passes arguments to functions by value. This means that if you have a local variable and then call a function passing it as a parameter, the act of calling that function makes a copy of that variable for the function. The function sees the copy rather than the original local variable. In effect, the function has its own copy, which is a local variable to that function. This is even the case for pointers. In that case, the function gets a copy of the pointer, but obviously not a copy of the object being pointed to. The other incredibly useful feature is the ability to create pointers to functions. This provides a form of extensibility for libraries by reducing the dependency among the different parts of a program. This becomes essential as a program grows in size and complexity. The syntax for function pointers can be a bit cumbersome. Fortunately, you can use a typedef to define pointer types for certain function signatures. Using a typedef then makes it simple to create function pointer variables.